So today is just day 2 of 10.1. I'm going to do a few additional examples to help you with the day 2 homework. So here they're telling us that point B is a point of tangency. So that's a clue that AB is a tangent. And we learned a theorem yesterday that when you have a tangent and it intersects the radius, it forms perpendicular lines. So it then will form a right triangle. So to find the radius of circle C, I need to do Pythagorean theorem. So if I go ahead and set this up, the 24 could be my A. If you want to think of it in terms of A squared plus B squared equals C squared, the R could be your B, and your C is going to be the R plus 16. So this is where we're going to bring in our foiling skills because we're going to have to square that binomial. So what we're going to do is my A is 24. My B I could say is the R. This is the radius that I'm solving for. And then the C squared is going to be the R plus 16 squared. So the first thing I need to do is square the 24 and square the R plus 16. The square of 24 is 576. Now it wouldn't have mattered if you put the R squared first and then the 24 second. And then now we're going to use our foiling skills. Do not just distribute and square the R and square the 16. You will get this problem wrong. So what you have to do is take the R plus 16, write it down twice, and FOIL it. So we get R squared for first. Outer gives me 16R. Inside gives me 16R. And then last, 16 times 16 is 256. So now I'll add my middle terms, and I get 32R plus 256. So now that is what is going to go here. And now I need to solve for R by starting to combine my like terms. So I'm going to go ahead and subtract R squared. Notice this time the R squared cancels. So this one's going to be a little bit easier. We're not going to have to factor here. But on some of the problems you will. So 576 is equal to 32R plus 256. Subtract 256 because my goal is to isolate R. And I get 320 equals 32R. Divide by 32. And my radius length is 10. So we're bringing back our foiling skills here when we square that binomial. Here they've told us that B is a point of tangency. So again, AB is a tangent, and then BC is the radius. And again, they're perpendicular, so a right angle was formed. So now to find the length of the radius, I'm going to go ahead and do the R squared plus the 14 squared equals this hypotenuse, which is R plus 7, and I got to square it. So R squared, 14 times 14 is 196. Again, I need to do R plus 7 times R plus 7. I get R squared for first. Outer gives me 7R. Inner gives me 7R. And last gives me 49. Once I add these middle, I get 14R. So now I'll put this in here, R squared plus 14R plus 49. And now I need to start combining my like terms. So I'm going to try to group my R squareds together. This will cancel. And now I'm left with 196 is equal to 14R plus 49. I need to get R isolated. So subtract 49. From both sides, cancels this from here, and now you're left with 147 is equal to 14R. Divide by 14, and 147 divided by 14 is 10.5. So the radius length is 10.5 or 10.5. All right, so for this one, we're going to apply that other theorem that stated when, and we could add in another point if you want. We could say that this is point X. So whenever two tangents, when they're formed by meeting at the same common external point, these two tangent segments are going to be congruent. So all I need to do here is set x squared equal to 9. I can either subtract the 9 and factor it, or I can use my square root method. So I'll square root it, and I get plus and minus 3. And you will need both answers because once you plug it back in, squaring -3 still makes it positive. So it's both answers. For the next one we got to factor. Now, this one could have also been solved by subtracting the 9 and getting x squared minus 9 equals 0, and then factoring it into x minus 3, x plus 3, and then setting each of the factors equal to 0. So this question could have been solved either way. So when you're doing the homework tonight, I will accept either way of showing the work. So -3 and +3. Now the next one, we actually have to turn it into a trinomial. So for the last example, again, these two tangent segments are congruent. So we would set this equal to each other. So we're going to set 2x squared plus 2x equal to 7x plus 12. So I need to go ahead and set this equal to 0. So I could subtract the 7x from both sides. I now am left with 2x squared minus 5x equals 12. Subtract the 12. 2x squared minus 5x minus 12 equals 0. And now I have a trinomial that I have to factor by grouping. So I need to multiply the beginning and the end. So I'm looking for factors of -24x squared that are going to sum to give me the middle. So my factors here, you could do your organized list, but if you've gotten good at this and you realize the factors are 3 and -8, that are going to be the ones that work, because when you add them, you do get the -5 that you need. So we would rewrite this 2x squared. We're replacing this -5 with the two factors we just found. It doesn't matter the order that you place them in here. And then rewrite the -12. And now I have to factor by grouping. So I'll make a group here of the first two, and then another group here. I'm looking for the GCF of the red group. It's going to be 2x. I'm going to divide. GCF of purple will be 3. Divide. And again, remember, what ends up in the parenthesis after you divide must be the same. So that'll be my first binomial. And then take the two GCFs, and that creates the second binomial. Now, the answer was to find the value of x. So now I have to take both of my binomials, set them equal to 0. 2x plus 3 equals 0. And this is going to have two answers. So add 4. X equals +4. And then subtract 3. Divide by 2. And the other answer is x equals -3/2. So you'll have two solutions here. So the whole reason why we did that whole review of factoring and multiplying was because it's now going to appear in Chapter 10. So these are going to be the type of problems you'll see. Some of them may just need a square root method. But again, all of those skills you're going to be using.